Welcome to Monochemistry. We're going to take a look at two KSP problems, two different types of KSP problems. There's type 1, where you're asked to solve for KSP, and there's type 2, where you have to calculate the solubility. Now, this is very similar to any equilibrium problems we've done, except for generally we're not trying to calculate the solubility. So type 1 is very similar, where we'll use an ice table to solve for the actual KSP, which is just the equilibrium solubility product constant. And type 2, well, we'll be working using the KSP to solve for the solubility. Okay, so in this case, KSP equals question mark. And in this one, we'll know the KSP. But we want to know the solubility. Alright, so I'm going to give you one of each type of question, and you have two options. You can either watch as I work through the problem, or you can try it on your own. Now, I am going to give you steps to solve each of these problems, but it's important that you try to do these without my help. I'm not saying you can't use the video, that's why I'm making it, but I would like you to try it. That's my preference. I'd like you to try it without my help first. Using the steps, of course, but don't let me just do it for you. I want you to try it on your own. You can check your answers with the work that I'll do. So question 1, type 1, the solubility of calcium sulfate is found to be 0.67 grams per liter. Calculate the value of KSP for calcium sulfate. Here are the steps that you'll have to do. Step 1, you'll have to convert grams per liter to moles per liter. As you know, no ice table can accept anything other than moles or molarity, and therefore we have to convert that. Step 2, we're going to find the concentrations of the products for our in our ice table, and then finally we'll solve for the KSP. So at this point, you can copy down those steps and try it on your own, and I, of course, will be working through it. Here's another hint. Assume you have 1 liter of the solution. .67 grams in 1 liter. And of course it's calcium sulfate. And of course you need the molar mass, which is 136.14 grams per mole. Okay, so we're going to find concentration. We need to convert the grams to moles, and then we already know we have 1 liter, so that makes it pretty straightforward. So go ahead and do the conversion, and let's see what we get. And here we have 4.9 times 10 to the negative 3 moles. Right, now we're going to calculate our ice table. And of course, that's going to be divided by 1 liter. So the concentration is the same, right? We assume that we had 1 liter. All right, so let's do an ice table. So we have our equation. Our calcium sulfate, which is a solid, of course, because it's a salt being dissolved in water, will dissociate into calcium 2 plus and sulfate 2 minus. Now, here's the thing. This is going to be the easiest ice table you've ever done, I would think. This guy right here, it's a constant. It's a solid. We don't include it. These guys start at 0. And they're going to be plus. Now, in the textbook, it talks about S. Whether or not that's because it's a salt or because we're talking about solubility, I'm not sure. I'm okay if you use X's. The textbook uses S's. But we know from the calculation we just did that the solubility of this specific salt is 4.9 times 10 to the negative 3. And same with this. Okay, so we know those values. That's what we just calculated. So KSP is equal to concentration of calcium 2 plus times the concentration of SO4 2 minus. This is not a trick, and therefore the KSP is equal to 2.4 times 10 to the negative 5. No units on KSP. There it is. That's how you do the first type. Let's move on to type 2. Type 2. Calculate the solubility of copper 2 hydroxide in grams per liter. Here are the steps. Again, after I give you the steps, pause it. Try it yourself. You're going to look up the KSP. You're going to create an ice table to solve for the unknown concentrations of copper 2 plus. And we're going to use the molar mass of copper 2 hydroxide to solve. Let's do it. Okay, so we look up the KSP. It's 2.2 times 10 to the negative 20. We then have to do an ice table for the dissociation of copper 2 hydroxide. Make sure you write the formula correctly. Copper 2 hydroxide is Cu bracket OH close bracket 2, which gives us Cu2 plus 2 OH minuses. Again, easy ice tables. Get rid of that. It's a solid. We don't need it. Both of these would start off as 0, and it'd be plus S and plus S. Again, I was wrong there. Remember, when you're dealing with equilibrium questions, you have to take into account the coefficient. So it should be plus S and plus 2S. So this is going to be S, and this is going to be 2S. Therefore, the KSP should be equal to the concentration of Cu2 plus at equilibrium, which is S, times the concentration of OH minus at equilibrium, which is 2S, squared. Continuing to solve for that, we're going to plug in, substitute our value for the KSP. We have 2.2 times 10 to the negative 20 is equal to, when we simplify, 4S cubed. Don't make this harder than it is. Solve for S. So you're going to divide by both sides by 4. And then you're going to take the cubed root. You need to find that on your calculator so that you can do that, so that you end up with S. So go ahead and try that. Excuse me. And when you do, the final answer you should get is 1.8 times 10 to the negative 7. And of course, the units of this are molarity. We're not finished yet. Remember, the initial question was to determine the solubility. And solubility in this case is in grams per liter. So we're working backwards from the previous question. So now what we need to do is we need to use the molar mass to solve for the solubility, which is grams per liter. So here I've written the equation. I've got my 1.8 times 10 to the negative 7. I've converted the molar into moles per liter. And now I'm multiplying that by the molar mass, which is grams per mole. Notice my moles cancel out. And I should be left with grams per liter. Go ahead and do that calculation, and you'll have your answer. And the final answer for this question is 1.8 times 10 to the negative 5. And that, in a nutshell, are the two different types of questions involving KSP. Hopefully you found them fairly easy. Bring any questions you might have to class.